All right, so in this video, I'm going to talk about some bond valuation basics. So really, if you think about a bond, a typical bond is going to combine an annuity, the interest payments, with a final payment, which is the face or par value. So basically what you have is if you have a typical bond, basically what you're getting is you get interest payments every so often. And then at the end of the bond, you get the par value, if you're the investor. So you get interest payments every so often, then you get the par value or principal amount back at the end, and those are the cash flows associated with the bond. So for a typical bond, the payments that are made every period are the same amount. So we have the same amount every period for a specified number of periods. So if that's the case, then this qualifies as an annuity. So basically, when I'm trying to find the value of a bond, what I need to find is the value or the present value of the annuity, the interest payments, along with the present value of whatever that final payment is, what we get at the end, which is so basically present value of an annuity plus the present value of a single future value lump sum amount that is received at the very end. So if you put that in equation form, you get this. Which if you look at that, it might be thinking, wow, what is that? All right, so let's work on this. So here I have M. This is the amount that is the par or face value that's paid at maturity. 1 plus RD. RD is going to be the discount rate that applies to the bond. N is going to be the number of periods. So what we're finding here is we've got a future value over 1 plus a rate raised to the number of periods. So this is finding the present value of the par value associated with the bond. Then I have this section over here where I have an INT, which represents the dollars of interest that's paid each period. And that is divided by 1 plus a rate raised to a little t. And I'm basically, but this sign here means that I'm going to start off with t equals 1 and then go from t equals 1 to t equals 2, t equals 3. And I'm going to do a whole bunch of these terms, one with t equals 1, a term with t equals 2, a term where t equals 3, a term where t equals 4, and just keep going until I get to n, however big n is. So basically what that means is this is the interest that I'm going to receive in the future. And I'm going to divide that by 1 plus the applicable discount rate raised to the number of periods. So basically what I'm finding here is the present value of an interest payment. Then I find the present value of the next interest payment, the present value of the interest payment after that. And I put all those together and I sum them all up. So really all this equation is saying is I'm going to find the present value of each interest payment. I'm going to find the present value of the par value that we get at the end. We put all of that together, and that is the total value of the bond. Okay. Now, as it turns out, if you're looking at this equation thinking, well, that looks horrible, it's actually not too bad to do this in Excel or on a calculator that has time value money functions. Basically, all we have to do is specify the number of periods, the rate, the payment per period or the annuity amount, so the interest payment, and then the future value that we get at the end. And you can solve for present value very easily on that. So basically, it's just a applied time value of money. So in Excel, you would do equals PV, and you put in the rate per period. You put in the interest payment per period. You put in the amount that's received at the end as the future value. Make sure that the number of periods and the rate per period line up so that annual and annual or monthly and monthly. And basically put it all in there, and there you go. So it's actually not too bad to do. Now, a few other bits and pieces. In a prior video, I mentioned the coupon rate. The coupon rate is the annual rate of interest relative to the par or face value, which is paid by the bond. So when they used to have actual like paper bonds, you actually get like a piece of paper. It would have on there like $1,000 par value, and it would specify a coupon rate of say 10%. And what that would mean is that 10% of the par value is the amount of interest that's going to be paid per period, or per year in that case. So we still have a coupon rate. We don't really do paper bonds anymore, but we have the coupon rate that is telling us what the annual amount of interest is relative to the par or face value. Now, again, it's worth reiterating, if you are doing a calculation to find the value of a bond, you have to be very careful that you're using the proper payment frequency for the bond and therefore the proper discount rate associated with it. So let me give you an example. Let's suppose a bond has a coupon rate of 10% per year, and it is a 30-year bond, and it pays semi-annually. So if it pays semi-annually, there are 2 semi-annual periods in a year. So if it's a 30-year bond and there are 2 semi-annual periods in the year, that means there are 60 periods total. 2 periods per year, 30 years, 60 periods. So we've got 60 periods. So N would be 60 in the example. Also, if the coupon rate was 10% per year, then I'm going to take the 10%, and since there are 2 periods per year, I'm going to take 10%, divide it by 2 to find out that it's 5% for each half of the year. So that means the coupon rate is going to be 5% per half year. So to find the coupon payment, I'm going to take that applies to that 6-month period. I'm going to take the 5% times the $1,000 par value. So 5% of 1,000 is $50. And so what that means is that the interest payment would be $50. The number of periods would be N, which would be 60. So 30 years times 2 periods per year, so 60. And then RD is the market rate of interest per period. So I kind of glossed over that a minute ago. So RD is the market rate of interest. So RD in this formula is not the coupon rate. RD is going to be the applicable market rate of interest. So let's say in the marketplace, bonds of this level of risk are generally producing interest rates of 12% per year. If it's 12% per year for bonds of this level of risk, then for a semi-annual period, I would take the 12%, divide it by 2, and that would give us 6%. So I would use 6% per semi-annual period. I would use the $50, which was half of the 10% coupon rate in my little example per period. And then I would have my par value of $1,000 I mentioned here. N would be equal to 60 because there are 60 semi-annual periods in a 30-year scenario. And so that would be what I would plug into the equation. So make sure that the payment frequency, so if it's a semi-annual payment, that the amount of interest that you're putting into that formula equates to the semi-annual amount of interest. And also make sure that the market interest rate would be a semi-annual rate. If it was a quarterly paying bond, N would need to be the number of quarters over the full period of the loan. INT would be the dollars of interest paid per quarter. RD would be the market rate, but per quarter. So I would take the annual and divide it by 4. And basically that's what I would need to do across the calculation. So make sure you're using the proper payment frequency of the bond and match it to the discount rate that you're using. And again, the coupon rate is not RD. RD is the market rate. The only thing I use the coupon rate for in this context is actually figuring out the dollars amount of interest that are paid. So the coupon rate is for finding the dollars of interest that are paid. The RD is the applicable market rate. So always, always, always use the applicable market rate in when valuing a bond. Okay, hopefully this helps. Thank you so much for watching and have a great day.